Welcome everybody to API Days in New York and our API Academy workshop and your API Academy workshop. My name is Bill. I'm going to be up here for 10 minutes and then I'm the marketing guy, so I'm going to get out of the way of the guys who actually know what they're doing. What I wanted to do is quickly do some introductions. I head up API Academy. With me is Bala and Daniel. They're in the back. They're actually field experts. They know what they're talking about, so they'll be talking this afternoon. Also with me is Francois. He is a member of the API Academy as well as CTO at Layer 7. He clearly knows what he's doing, so he'll be talking. And then Gary is actually one of our field experts in the UK, and this afternoon he'll be dialing in and actually presenting live online. And then Skip is a partner. He'll be in a few minutes, and he'll be working with Franco later on. And regardless of what you saw on the API Academy schedule, that was a really loose schedule. This is the tight schedule. So this is actually what we're going to be following today. The bold is our tight times, obviously not too tight since we just started, but 12:25 we will break for lunch, and around 3:15 we will start our wrap up to end at 3:20. For my purposes and each individual, so you guys remember to do this, can define how they want to handle Q&A. If you have questions while I'm up here, fire them away and I'll do what I can to answer, and if I don't know the answer, these guys in the back probably do. All that makes sense? So first of all, what I wanted to do is give an actual history of API Academy. How many of you have been up on the website or are familiar with API Academy in general? Anybody? Nope, okay, it's a hidden gem. Basically, we started this back in 2011, and it was started with one thing and one thing in mind only, and that is to help enterprises transition away from these heavy lifts of SOA and ESB. How do you basically not replace them, but how do you basically extend them beyond what their capabilities are and take advantage of this emerging, at the time, world of APIs? And they basically hired this guy right here, Matt, to basically set up the program. And he brought in Mike, he brought in Eric, Ronnie, Amy was in charge of the overall learning cycle, the learning process. And then Mehdi, you guys might know him from here, from API Days. And basically all they did was, again, do that aid for enterprises and how to transition beyond SOA and ESB. And they held worldwide workshops, or I mean, everywhere around the world. If there was enough people that were interested, they would fly out and put together an all-day or 2-day or 3-day workshop at enterprises or at events like this. And then the other thing they did in their spare time was write these great blogs and shoot these great videos on either thought leadership or how-tos for, again, API evangelism. This model was in place from 2011 to 2018. Now, anybody knows what happened in 2018? Yeah, we do. CA Technologies, which owned and funded API Academy, which was in no way, shape, or form a profit center. It was purely about goodwill toward the industry, about helping the industry in general transition over to API management. Broadcom doesn't work that way. Flat out. So what they did was, with the help of a few of us, we basically said, you can't kill API Academy. It's just too valuable to the industry. So what we did was put together a different kind of plan. I'm going to cover that in just a second. But during this model, it was actually kind of interesting. Literally, API Academy wrote the book on APIs and microservices. In a period of about 6-7 years, microservices, securing microservice APIs, a guide to REST and API design, microservice architecture, et cetera. I'm not going to go through all of these, but the bottom line is these books are still available today on Amazon, and I just lost the name. Oh, O'Reilly. They're also available there. Or you can go up to API Academy and download them. It's up to you. I'm cheap. I'm going to go the ladder up. But bottom line is they are still out there today. They are still absolutely valuable resources to have. So let's fast forward to today. We changed our focus. The bottom line is APIs don't need evangelists anymore. APIs are very much a core of virtually any enterprise that's still in business. So the focus really shouldn't be on evangelism getting out across the world. It should be more around best practices for API design, API strategy, and certainly API and microservices security. So that's basically what our shift has been. We've also renewed our focus on education, thought leadership blogs, and how-to videos on the website. So the website stays very active, at least 2 to 3 updates a month. And we also rolled out 2 years ago the API Academy certification program. And this was my baby. It is the first and remains only place you can go for education and certification for strategy and design for APIs. Period. There are other ones out there, but you're going to be paying lots of money. This is actually a real certification program that you can go through a lot of fun and games to get through, take a hardcore test. It is not the, oh, you watch this video, so this test is going to be a breeze. No, you actually have to understand best practices for each one of these areas. But we do what we can to help you get there. They're personalized, they're self-paced for API designers. These are personas, they're not people. It's not about the technology, it's about the persona. What do they need to be able to do their job? So designers, security architects, and product managers. And again, it's all about proven best practices, and it's all about on demand. Each course completion, you do get a certification. I'll show you one of those in just a second, and a badge. And we like to see people go up to our API Academy LinkedIn page and show off your certification. So that stays pretty active. We also deliver worldwide in-person training, but not to the same level we did before, and not for evangelist purposes. It's more about events like this where we come in and talk about best practices and listen to you guys and what you guys are doing. Visit API Academy for more information. It's apiacademy.co. Now, if you want to go through the certification process, this is actually the homepage for API Academy. And if you look in the upper right, there's Get Certified. So if you go over to Get Certified and you decide you want to be certified as an API security architect, you're going to click that. And that's going to basically give you your dashboard for this particular course. These depending on what the subject is, they can be anywhere from 30 minutes to a couple hours each. And at the end, you can see step 6, security exam. And again, I cannot emphasize enough, this is not a check the box because you watch the video, you can pass this. And that's what it looks like. And the only reason I posted this one is I did one better than one of the other guys here, Aaron. So I just like to point that out. But that's the certification you actually end up with. And so with that, I'm going to get ready to turn this over to Francois. But what I do want to summarize with is API Academy is doing incredibly strongly. It is all about best practices for APIs and microservices around strategy, design, and security. Our website will continue to be updated to reflect that. Again, apiacademy.co, and you can learn more about API Days and API Academy workshops. And finally, the certification program, it is available now, today, at no charge, and again, for these personas. And with that, before I turn it over, any questions for me, or do you guys want to get to the meat? Then take it away. Yep.
I'm going to put this here. All right, sounds like I've got some audio now. Test. How is this working? Okay, I'm going to mute my. Yeah, it's going from there. Okay, let's get started. Yes. So, hey, hi everyone. We have a tight group. Thanks so much for coming. This is going to be casual and it's cool. I'm actually not here to sell you anything. We went through this process of building a GraphQL API over the last few months. We learned a lot of lessons, and you know, if anyone here is maybe in the future building a GraphQL API, then what I hope you get out of this is some things that is going to allow you to maybe fast forward to maybe a few things that we went through. If you're an expert in GraphQL, maybe you can contribute to the conversation, or anyone obviously is welcome to contribute to the conversation. And if you're not into GraphQL at all, then maybe you just learn a little bit more about GraphQL. So I'm going to talk about the use case, why we need to build an API. I'm going to talk about the GraphQL design and developer experience considerations that emerged from that. And I'm just going to wrap it up with a little bit of where we're at, how we're moving forward, and stuff like that. All right? So this is my use case. By the way, I come from layer 7, and 20 years ago, we created this API gateway, which again, I'm not here to sell you today. But yeah, we didn't realize at the time, but 20 years later, we have the situation where people build a lot of value on top of this, and this is valuable to us. And the way that this, if you think about how people create value with our product is by, it's all about configuration, not code, right? That's kind of been the layer 7 thing from the beginning, right? So you define services and policies and connectors and data sources, and you subscribe to topics, or you've got patterns that you're arranging together, and you build these things together, and it creates this thing that is really meaningful for the customer, becomes, 20 years later, to a certain degree, part of some legacy infrastructure. But that configuration is the key to the value that the customer get from our solution. And so it's really important for us, right, to nurture this configuration and to allow the customer to govern it. So configuration management capabilities that are targeted by the API we're about to talk about are bundling configuration, applying configuration, copying, mapping, some configuration arithmetics, analyzing dependencies, right? We're talking about each customer has a unique combinations of thousands of interrelated entities, right? So it's really, really complex from a dependency perspective. We want to enable customers to do configuration as code. We want to allow customers to break their monoliths through that. And we want to power the future ops capabilities that we are releasing as part of our product with a solid foundation. And what happened, I'm just going to wrap up the use case here, is that we have this legacy API called RESTman, which is a REST-based API. It's XML-based. There wasn't, the perspective that we have 20 years later now, how important a component this is. Therefore, there maybe is not enough design thought put into it. It's really important for us, right? And so that has been identified as something that's keeping us from delivering the maximum or optimal configuration management capabilities that we want. So the new API has to be able to enable the bundling and managing of configuration as code. It has to allow for flexible grouping of different entity types, because different customers use and create configurations in different ways, right? Sometimes they break it down per API they're exposing. Sometimes they break it down per teams, so there's a lot of granularity that's different from customer to customer. We need to be able to analyze dependencies, but also the deltas between different gateways. So, customers go through revision history, and so basically you've got last week's configuration versus the one that you're about to deploy to staging. And so you need to figure out what is the delta between that. So in general, just easier governance of assets developed with layer 7, and also allow customers to break those monoliths, right? You've got this massive configuration, but the trend now, when people modernize their infrastructure, is instead of having these big monolith API gateways, is to have smaller API gateways that have fewer services listening on those gateways, because it makes it easier for you to scale a particular service or another, or things like that, right? From a DevOps perspective, that's just the trend, the current trend. So how did we land on GraphQL? We did an initial spike. We had this old API. We knew we could do way better than that. So we just did an initial spike, simple REST JSON API. We looked at GraphQL, because we realized that we could get a lot for free. And some of the requirements we were getting were things like, hey, I want to be able to get those policies, let's say, defined on the gateway, but I don't want all of the policy. I just want maybe the names and a checksum of it because I want to be able to do those deltas and stuff like that, right? These XML documents that you get from the legacy API, sometimes you get like a single XML document that's like 90 megabytes, really, really hard data to work with. We did a limited implementation for some initial capabilities, and it really performed well. One of the issues with our legacy API is the performance. Sometimes customer will try to pull the configuration, and it will take almost an hour for it to come back. Sometimes there's timeouts involved. It is definitely problematic. And there's the data is so complex that it really needs to perform. And GraphQL in that initial spike realized that, holy cow, this is really fast. So we stopped implementing that spike, and we just looked at design for a while. We spent months and months figuring out how this thing should look. The GraphQL schema aspect of it was definitely the most time-consuming from the perspective of building this API. And then we just started implementing with this new, more sophisticated, I shouldn't say complex, more sophisticated schema, and we're still moving that direction right now. Can you see okay there? Yeah, feel free to move if you want. So, yeah, I don't have a slide on what is GraphQL because I'm hoping people are past that, but just in general, in case you're not, right, GraphQL has GraphQL queries and GraphQL mutations, right, which is different from REST, where you have different verbs, right? So a GraphQL query is kind of like a REST a query where you do an HTTP GET, typically, right? Whereas GraphQL mutations are would be the equivalent of an HTTP post and HTTP put. So mutations are writing the data, and query is about getting the data, right? So the query, the syntax that we adopted so far is on the left here. So we have no verbs in the queries, right? Trusted certs by DN, trusted certs by thumbprint. There's no verb. We use the by in this case. We have a simple input type. So in the case of trusted cert by DN, the input type is just a string. But we were really tempted, and we're still considering adopting a more sophisticated query syntax that looks like this. So notice how here there's only one query. It's called trusted certs. But the input itself is not a simple type, right? In this case, I have a query input in which I can put filters, and maybe I want to be able to sort the data coming back. Maybe I need pagination, stuff like that. We don't actually need those things right now. But the reason we're considering doing that, and that's like a really key thing about GraphQL, is to allow for the API to evolve without breaking the previous clients that have been implemented on this. So by creating a wrapper input type into a query like this, allows you to evolve over time, right? We don't need sort and pagination right now, but yeah, maybe it would be nice to have filters instead of having 3 different queries by this, by this, by that. There's a filter, and then I can put these input parameters, right? So the ability to adding this wrapper input type is something that we think is going to help us over time when we evolve the API. One of the things about GraphQL that we ran into a couple of times that is a challenge that we needed to overcome was the concept of these recursive type, right? Consider like a folder system, right? So in our layer 7 gateway, you organize policies and service in a folder structure, and the customer decides what those are, right? But a folder has subfolders, so you could technically have infinite nesting. And that, when you want to query data and say, you know, give me all the subdirectories of a particular object, GraphQL doesn't lend itself to that because you have to be explicit about what you're querying and all the properties inside of your query. So the depth cannot be infinite, and you will run into this. If you read a little bit about GraphQL, that is one of the things that people run into very often. So the depth cannot be infinite. It needs to be explicit in the query. That is you know, something that we ran into. So here's the first way that we address this. The first mitigation, not necessarily mitigation, but it caused us to rethink about our object model, right? We have an API that's in front of in this case, a Java object model, but we can take the liberty of interpreting this object model. So for, in our object model, there's an object called folder, right? But what really realize is that, well, what's in folders? What's in folders are services and policies. So we just have a property called folder path in these types, and we just say, you know what, folders don't exist. So our API now, if you are doing a mutation where you're setting services and policies and you specify a folder path, we're just going to create the folder object on behalf of the caller, and just, we basically reimagined the object model in a way that the folder object doesn't exist anymore. When you do mutations, maybe you end up in situations where you end up with empty folders. So if there's no folder entity type, you can't delete it. So we automatically delete things that are left empty, right? Recursive type pattern mitigation number 2. So it's very important for us to do dependency analysis when we are looking, for example, in our case, policies that are applied to services. And because with layer 7, you can define a policy and then you can have an include statement that includes that policy, you basically organize your repeated logic for your APIs in these policies, and then you just inherit them along to the top level policies that are associated with services. So that means that we have another recursive situation, because a policy can include a policy, can include a policy, can include a policy, and we want to be able to distinguish between just getting the top level dependencies versus going all the way down the dependency stack. And so the way that we address that in this case is by introducing 2 different properties, direct dependencies and all dependencies. And in all dependencies, you basically get back arrays of the different dependencies, and they're flat. And the fact that they don't embed each other doesn't matter, because in this case, I want to get all of the dependencies. And technically, I could go direct dependency, policy fragment, and get the dependency of that. And I could do, like, if I want to get only 2 level down, you could still do that if you want to. But now you also have a way to go all the way infinite that by implementing that on the server side of the API. Okay, so we're still talking about queries and GraphQL types of challenges that you get into when you're designing an API. Here's something that pretty quickly we ran into. Right, just the case of, like, give me everything for your API. Just query everything. In REST/everything, you're done, right? Let me just show you, like, my query everything right now in Postman and show. Why isn't this working here? So, one of the things that really made us doubt our approach was this. So look to bundle migrations. Let's look at my graph bundle all. Here's my query. This is just to say I want to get everything, right? So 60 lines, and it's growing. So we're at 60 lines now, but it's still growing. So how is this a problem or not? And what are some of the mitigations? The mitigations is like that Postman collection that I was showing you. You don't need to adjust the query. You just say send, right? The query is called everything. There's documentation about it. So if you don't need to change anything, the same way that you would do with a REST API, you can have the same developer experience by providing things like Postman collections. We have command line interface wrappers to, like, curl, for example, where you have sample queries that you can apply, and those queries themselves are hard-coded. We've also considered adding REST shortcuts to our GraphQL API so that you could go GraphQL/everything, and then on the gateway side, we don't actually have to implement that in the GraphQL API itself, because we have our own policies that are governing that, so we can just translate that into the everything query. But we're actually not moving forward with that at the moment, because we find that the complexity that you're getting from that is shielded by those mitigations by providing a DX that doesn't focus on the GraphQL details themselves. And I'll get more into that later. And We also rationalize this over time. I think now I don't see it so much as complexity that we're imposing on a DX, but rather as verbosity. It is true that it is verbose, it is specific, but there are definite advantages that we're running into, definite advantages that I'll get into later. So another complexity that we are running into, or that we ran into, was basically the query response formatting, right? So imagine I'm getting configuration out of a gateway. I use a GraphQL query to get the data, and then I want to apply it to another gateway, so I would do a GraphQL mutation on my target, right? So the output of the query is what should be your configuration as code, and that is also the input into applying the configuration to target. But the corresponding GraphQL flow doesn't actually work just like that. The JSON that you get back from the query can't itself be directly applied to the mutation. So that's something that you're like, huh, that's kind of annoying, right? But here's one of the reasons this is happening, right? So we're doing some dependency analysis for a web service here. And so deep in there, we're finding dependencies that have their own policies and stuff like that. When we apply a bundle of configuration, we want to apply a flat bundle where all of the policy fragments are together in one area, regardless of who they depend on and stuff like that. So we need to massage this information. In a GraphQL response, you have this prefix data, as part of that, which also you don't want that on the input necessarily. And there are ways that you can in a query, control a little bit how the response goes, but not sufficiently that we don't need to do transformations. So how do we deal with that? Because it's all JSON, and on the client side, JavaScript's definitely your friend for that. It's been really easy to address that on the client side, right? So again, when you think about the developer experience, that's the kind of tooling you provide to developers so that you don't have to think about things like that, but you can go in and tweak it if you want to. So I'll show you a couple examples. How am I doing for time here, Bill? About halfway?
You're good.
Okay, cool. Right, so if you look at, for example, when I bundle configuration, so I have this Postman collection that I would give a developer, right? So bundle and configuration, I want to get a service and its dependencies. I've got this create bundle query that is going to give me a response. And before I apply the bundle here, notice how the GraphQL variable is an environment variable called package by resolution. So basically, what this does, in addition to, I can probably just run it. Yeah. So yeah, I don't have this, maybe /demo. Yeah, so here's what my response looks like, right? Data, and there's the dependencies in there. But there's an environment variable that has been set called package by resolution, and that has its own format, right? So, and the way that we are doing this is by using a Postman test script. So you just plug in your JavaScript in there, and so it just runs after your request comes back. So Postman test scripts are very convenient for addressing this, and also this is what the DX looks like right now. You get this README and stuff like that, and there's a bunch of samples and utils, and there's a bunch of different JavaScript to do various operations with the JSON that you're getting or inputting into the GraphQL API. So that's working really well. And so there are additional pre-existing reasons for differences between the input and the output, right? So in the case of configuration, you want to apply some environmental mapping. You want to templatize a configuration. So it is you could not, even if there was a way to format the response in the same format, you still would need to make changes, right? There's secret management that we need to deal with as well. And this just general massaging of data, maybe you want to combine different services or different versions together. Okay, so we talked a lot about GraphQL queries. Let's talk about GraphQL mutations. So here's what we settled on right now. So you have to think about, in this case, we have verbs, right? So in the case of queries, you didn't need verbs because you're just always getting data, right? Whereas in mutations, you're doing applying different things. So then we have things like verbs. So create, update, set, and delete. So create policy fragment, update policy fragment, set policy fragments. Notice the plural here. And so set is kind of like a combination of create and update, where you're passing an array, and the API is trying to be smart about if things already exist. So I'm going to update and try to make sure we don't override any dependencies, conflict, and things like that. So that's how we distinguish between that. And it's also a mutation that allows you to apply multiple entities at the same time. And then delete policy fragment. Separation of input concerns. So for example, in the case of update, you want to update a policy fragment. We separate what is required to identify the policy fragment from what we're actually changing about it. And then that separation is something that we didn't actually have at the beginning. We had only this type, and inside that type, we would read something about it in order to identify the target of the entity. So for example, the name. But by separating that, you've got a cleaner syntax, and it also allows you to do crazy things like, I'm going to update a service by changing its name, so it's a completely different service now, right? Or you change its ID or something like that. So sometimes you have one, sometimes you have both, sometimes you have the other. So in the case of delete, you're only identify what you're acting upon, as opposed to update, where you need both. If you're creating, you don't need to identify, you just need to provide the input. So those are the three different patterns. And under consideration is, like if you think about advanced mutations, what we'd like to do, we'd like to have an optional input property that are unused during a mutation. So for example, we calculate checksums in GraphQL queries. That's one of the options that you have that allows you to do impact analysis before you apply the data. But the checksum is not a property that you write into the data model itself, but it's still nice to have the option to include that into the data so that later on, before you apply the data, you can do an impact analysis. So that's something that we read into. Mutation payloads. In GraphQL, the response of a mutation is called a mutation payload. And the best practice is that each mutation has its own custom payload type. Initially, we were just returning the entity itself. And then we realized that, hey, no, we need to protect ourselves from the evolution of the API. So we have right now very simple entity types that we have a lot of ideas about expanding, right? So yeah, if you do an update policy fragment, we'll get you back the policy fragment. If you create a policy fragment, we'll do the same thing. But here are some of the ideas that we already have in our mind to extend those. So we don't want to wait to do everything before we can share the API with our initial customers, but we know we're going to want to do this advanced stuff. So for example, a rollback property. So in addition to the policy fragment that you just set, what if I want to specify another property that gives me like the reverse thing that I just applied? And that allows me to do a rollback. We didn't actually have that in our legacy API. We kind of try to do it, but you don't really have a way to do a rollback until you actually apply the data, because you need to roll back to the state right when you apply the data, right? So this is a case where the API can generate the rollback as the mutation is being created. For example, if you're setting a bunch of policy fragments, I can imagine that we'd like to be able to distinguish between which fragments were set versus which ones were updated, right? So we're going to extend that. Yeah, there's a whole bunch of other things about like delete, or people also in payloads will sometimes have the concept of errors. So the GraphQL best practice is, it's kind of weird coming from a REST perspective, but errors actually come back as an HTTP 200 with error information in the payload itself, depending on which layer the error happens in. So this changing payloads allows you to specify errors. So let's talk about, we've talked about a number of issues and a number of things that we had to go through when we designed our GraphQL API. And my concern is always the resulting client-side developer experience. We are trying to help our customers here. So we're always second-guessing ourselves. Is GraphQL too complex for this? But I think that using samples, customers would adopt this in a way that with only minor tweaks, they would be able to use this without being barely aware of the GraphQL layer, right? When I'm using, something that looks like this. So, right, I get this README. There's a bunch of utilities, right? In this case, we've got Bash scripts, we've got some Node.js utilities, and we've got documentation that explains you how to do it. Sure, there are samples, right? For example, in here, if I go sample bundles, here's, I could give this one, no, not this bundle, but maybe how to create a query. So how do I do my everything query, right? There's actually no input, so I don't need to change that. But maybe in this query here, I would change, which folder I'm targeting. I want to get everything in that folder, right? So this query part is not something that I need to change, but in the documentation, I know that if I want to get a specific folder, I would just put its name here, right? So that would be the extent of my exposure to GraphQL in that type of developer experience situation. So what is the actual API then? Is it the GraphQL API? Or is it the client-side tooling that you add on top of it, right? If you're people are using REST APIs right now, they're already using things like SDKs and generated code snippets. If you're using like a protobuf, you're using a .proto file, right? It is not unusual, Postman collections, obviously, right? These things are there to help the developer adopt your API. And hard-coded queries, mutations, HTTP post wrappers, straight JSON manipulation. This stuff is, I would argue, still lighter weight than providing your developers a .proto, in my opinion. I'm not partial, I guess, on that. But so why does that GraphQL layer exist then? You could argue, like, if users are never going to go to the GraphQL layer, why do you even bother? Because it is complicated stuff for us to build. But what it is for us is that it empowers advanced users, right? Right now, I'm giving you an example with my tooling of how you can bundle the configuration together and how you can apply it and how you can do things with it. But we have consultants that are helping our customers. We have like support people that are expert users of the current legacy API at the same level that our customers are not necessarily, right? We already have like this client-side tooling for our legacy REST API, and that's the layer that our customers are working with today. But we have a few advanced power users that will want to go in that layer, and that helps me sleep at night because I know that it's going to protect us from being able to do more advanced stuff with our customers. So if you want to tailor how you package configuration, if you want to specialize analysis, right? In a troubleshooting situation, there's a lot of analysis power you can get out of this. If you want to build, imagine a configuration governance solution, right? Let's say I want to build a distributed authorization governance solution. You could do a killer GUI with something like a GraphQL API like that, right? I'm not saying we're necessarily doing that, but some partners do, right? There's a company called Apidays that built an entire product around this legacy RESTman API. They would love this. Then they're gonna wish they had that 10 years ago for sure. So in conclusion, am I early, Bill?
Yeah, you're running a little bit early, but
We can have either a break or some questions or. But yeah, I would say that right now, GraphQL as a choice is already paying off. So, and the way that it's paying off is that we already notice instances where there's innovation happening on the client side, on the requester side of the API. So I know that I'm empowering future users of this API by doing GraphQL. So we ran into, for an example that I put in here, is this concept of GUID conflict. So we had these UUIDs and configuration, and sometimes, you know, a customer, instead of like taking the configuration and moving from like a development to a production, they're going to like create a little delta manually here and then move some stuff, and that creates conflicts in object IDs that are, you know, inherited in your policies and stuff like that, and then you have to like manually resolve those and stuff like that. So just by crafting GraphQL queries of our existing GraphQL implementation so far, we have a really, really easy way to just give you the list of those conflicts and to actually go back and apply those modifications in your bundles. So this is an instance of innovation that happens on the client side. This is not something I build on the API itself. This is something that the tooling can do because GraphQL is very flexible. So where we are so far, you know, I would say half of the work easily has been in designing the schema as opposed to retrofit GraphQL into our application. That part has been surprisingly easy. We're using GraphQL-Java because it's Java. It really easy plugs into our existing object model. We just create resolvers and wrapper into the existing Java objects that we're trying to front with this. From a performance perspective, depending on, you know, the use case that you're using, we've observed 10 times faster to 100 times faster than the legacy API that we're replacing. It's not complete in the sense that there's just so many different entity types that our object model exposes. And so we have partial coverage like that. And we're kind of like alpha stage right now, where we're targeting internal developers, and hopefully our customers are going to see the benefit of that in a few months. So who's building a GraphQL API in here, maybe? And any questions or?
Well, Skip is here, so it's up to you guys whether you want to take a 5-minute break or if you want to just keep going through and get the lunch a little early. Take a 5-minute break, okay.
Thank you very much.
Thank you.
Okay. Ready to go? Okay. All right. So in this next session, we are going to talk about API security with a focus on what I call confidential clients, but it will become clear as I go, like what exactly are we talking about? It's a subset of API security. So just a little bit of context. So why secure API? Why is so many people talking about API security these days, right? This is about protecting your APIs from attack, because APIs are a critical component of modern applications and very much a dependency of, in many situations, your application. So when your API goes down, your application also goes down. APIs allow access to data, and breaches happen through APIs. There have been numerous examples of that. And just in general, I would say attackers look at your APIs as a prime target, right? They skip the client-side application. They try to reverse engineer the API if it's not clearly documented in the first place. And they just try to find a vulnerability. So API security has a really, really wide scope. There's a lot of people involved in making an API actually secure, right? So you want to catalog your API. Some people talk about API discovery. You want to have an inventory of your APIs, because a lot of security incidents happen when people don't necessarily have visibility over the existence of an API somewhere in your organization. You want to find and you want to apply policies. That's a huge aspect of it. So think about runtime API policies that you apply to API traffic, right? So things like authentication, controlling access, so access control rules, rate limiting, input sanitization, threat protection, and things like that. Those are all things that runtime API policies can do. So that's part of API security. You want to find and remediate vulnerabilities. OWASP is a great source of information that talks about what are the top vulnerabilities that you should look for in your APIs. You also want to monitor APIs as a part of API security scope, right? You want to monitor your APIs from the inside and from the outside. From the inside, you can tell how busy is your API, how healthy it is, and stuff like that. And from the outside, you get the perspective of how, like you want to make sure your API is accessible from different geographies. For example, there's no DNS issues. There's nothing in the way between your clients and your APIs. And analyzing API security, analyzing API traffic is also part of API security. So I would argue that two critical ingredients to successfully securing your APIs are trust frameworks, right? There's no security without that, and integration. They're critical ingredients, not just because you don't have successful API security without it, but also because they are not, those can be really complicated things. So I'll give you a couple an example for each, and before I pass the skip here. So integration, right? So we are an API gateway solution, and we're definitely in the middle of that. When customers do API security, our gateway needs to integrate typically with an identity management solution, for example, and things like that, right? But even if you look about, if you think about AI or behavior-based API security, right? So, Willy Wonka is selling you this big data solution, does behavior analysis, machine learning, AI. It models your API traffic, crunching the numbers, looking for anomalies. So how is that API security, right? And the way that's API security, that's important, is that in the API layer, you need to be able to derive data from the API traffic that's relevant for that solution. So that's integration, right? You need to instrument that everywhere in your API. And then on the reverse side, if your AI engine discovers something that's a threat, and then you need to maybe block a specific client or a specific token or something like that, you also need to instrument that into your runtime API, right? So this is how this API security. So integration, there's a lot of different examples of where integration is required to make API security work. And API security relies on trust frameworks. Trust is what allows integrity, right? Make sure that the data that comes to the API is coming from the client that's supposed to. So there's a lot of different trust relationships, right? If you think about the client-side application needs to trust the API. So what is the trust framework for that, right? So through DNS and certificates, in some cases we utilize things like certificate pinning. That allows a client-side application to trust an API. The API itself needs to trust whoever the token issuer is, because very often that's a different party, right? So there's a trust relationship between the runtime API policy enforcement that applies the authentication rules and the token issuer. Again, that's very often based on PKI, like certificates or a shared secret. The IDP, the identity provider, needs to trust the user, right? And that's typically a password. That's how you know that it's your user. Or maybe there's some MFA or some FIDO involved. And now the IDP trusts the user based on that, issues a token, which itself is trusted by the API. So there's a lot of different layers of trust, right? And the one that we're going to focus on in this presentation is how does the API trust the client application itself? Right, so people have been using things like API keys to say, this is the application that's calling the API. Right, we're not talking about the user here. We're talking about the client application itself, and that's difficult. A lot of people have been struggling with that. I met a lot of customers. It's like, but how do I know for sure? Like, is it a mobile app? Is it on a public app store? How would you expect? Right, you can't expect that this is the application that you release because somebody's going to reverse engineer it, get the API key out of it. So you don't really know. And then that has security implications. So I would like to invite my esteemed colleague, Skip, from Approved to deep dive on this topic of client attestation. Over to you, Skip.
Thanks, Francois. I'm not sure I've ever been called esteemed before, but I'll take it. Oops. And I just dropped the mic. Wow, what does that mean? Okay. So my name is Skip Hovsmith. I work at a company called Critical Blue on a product called Approve. And we're focused very much on mobile security and API security together. And I want to talk to you about client attestation and some of the real pieces I think are missing that we can improve on. So the focus when I talk to customers is quite often on, gee, we got to make sure we know who the user is, and we really have to protect the back end. And my focus is on everything in between those things. Establishing trust, as Francois said, in the app itself, in the device it's running on, and in the channel between the app device and the back end. So I'm going to focus primarily on mobile apps. I'll touch on web apps a little bit towards the end of the presentation. Here's what you're working with. You've got a mobile operating system that the good news is there are some roots of trust with hardware-backed kind of operations and secure enclaves and trust spaces that you can leverage to establish some core trust. And there is a decent model of application sandboxing. So one app cannot get into another app's sandbox, and that mostly works. And then the apps themselves, contrasting that with web apps, have the ability to inspect themselves. So they can introspect their code, they can look at what's going on in their environment, and they can participate, therefore, in their own defense. Attackers, though, have quite good advantages. First, they own the device that they're running the application on, so they can do whatever they want to that application and to that device. The application itself is in a Play Store in the public domain. People can go and access it, take a look at it, and start attacking it directly. So it's relatively easy for attackers to get in there and see what's going on and do their best to attack and cripple the application. So API keys are kind of the canonical way that we typically defend APIs by giving a secret to an application, which will then present that to the API to say, here, trust me, I have the API key secret. Unfortunately, the API key itself is kind of like cash. If you have it, it doesn't tell you anything about who you are. I could be a real bad, evil guy who somehow got my hands on an API key, and I can go and use that key just like cash. So these keys, unfortunately, are on mobile devices pretty easy to steal. If you want to find a secret and you're willing to work hard enough, you can usually always extract it. There are plenty of tools that exist in various domains to go ahead and help you do that. Many of these tools serve honorable, good purposes, but they can also be used for malicious ends. So you can find secrets that have been inadvertently checked into GitHub repos, for example. You can take the app code that you got in the public domain and you can reverse engineer it, take a look at it, break through obfuscation and see what kind of hard-coded secrets can you find in the app. API keys being probably the #1 thing that you'll find there. You can exploit the mobile environment to try and hook into areas to try and observe or change behavior of apps in order to get your hands on some of those secrets or user credentials even. Then you can also, even though you are likely protecting your channel with TLS, there are ways to exploit and break that trust model and get in and man in the middle and extract all sorts of stuff and see every API call that's being made. User authorization, the good news about user authorization with OAuth, for example, is that there's a pretty good model that's defined that allows a user to grant access to an application to go ahead and make an API call through, and the back end doesn't know a lot of the PII and credentials, passwords, etc. of the user itself. So good model. But again, like API keys, it really doesn't guarantee too much about the app. When the user goes to sign in, you usually see a screen that says, is it okay to proceed? And if you click that, you're basically saying, yeah, I think this app is pretty good. That's not strong security. And most people just click through right away. Additionally, in the kind of back and forth that's going on, there is a client ID and a client secret, static secret. Looks a lot kind of like an API key ID secret pair. But even in this model, that secret is recognized as being easily stolen. So on a mobile device, we don't even count on that secret being there. And we use some other methods to try and do as good as we can at guaranteeing things. But it's just, you can't, none of these protocols are guaranteeing the behavior of the app itself that's making the request to get authorization to your backend. So in a typical mobile attack, if I was trying to break in and see what I could get in your backend through your API, I control the device. So I would go ahead and start probing everything I could find. I would start with a static app and use some tools to see if I could extract any keys, whatever other kind of secrets you have lying around in your app, and start collecting those. I will try and root or jailbreak your device, so I'll try and get root permissions so I can break that app sandboxing model and walk around and see what else I can find and get access to, still collecting credentials and secrets as I go. And then I will exploit the runtime, adding instrumentation frameworks, for example, like Frida, to allow me to hook into the application that's running, and where you are saying, am I safe? And the function's going to evaluate something and come back with a yes or no. I will hook that call and say, yes, of course you're safe, continue. And so you can manipulate it that way. You can tamper with the app and recompile it and rerun it, and repackage it. So you've got a lot of buttons that you can push to amass the credentials and the secrets and everything you need to go through, understand the API calls. And once you have everything you need, then your next step is to move to an exploitation phase. So here you've got what you need to impersonate an app and start making API calls. So you can either start sucking data out, or you can start manipulating backends. You can try and degrade customer experiences. In, for example, a sales application, you might go in and notice sales are coming up, and you might try and put orders into shopping carts for everything that's popular to try and drive customers off that site for whatever reason. You can also launch very sophisticated DDoS attacks that are launched at the application level. So they're not so easy to stop at the lower levels because these look like legitimate traffic, legitimate API calls that I'll just make calls that I know are going to use some expensive database operations, just pile them up. So it's really hard to back off on those kind of DDoS attacks. So this is a financial payments app. This is traffic on that app over a 24-hour period. The top are successful uses of that API, legitimate uses. The bottom is failures. Now, it's only a couple percent of the overall traffic in this, which is pretty good. This is a very well-defended app. But the important thing to note down here is 24/7, there is constant probing of this application. Can we get through? Can we see something? Is it worth our time to go further? So the good news is that what you want to do is invest enough that breaking your API is expensive. It doesn't have to be perfect, but if it's more expensive than the other guy, then the attacker will pivot to the other guy. So people say, okay, great, I've got API defenses in my backend. Isn't that good enough? Well, the backend is going to, of course, check the API keys, check that the user is authorized to access your API. But from there, you're sitting in the back at the end of the process looking out, and you don't have all the information that you could have at that point. So some typical things you might try, Francois mentioned rate limiting. So in that case, you're trying to look for too much traffic coming towards your backend. At that point, you'll start to shut it down. There's a typical leaky bucket model that's used. When that bucket fills up and it's not leaking fast enough, then that short circuits some evaluations. Unfortunately, you start killing traffic, you don't know whether that's legitimate traffic that you don't want to kill or illegitimate traffic that you do. There are behavioral type approaches using machine learning, for example, where you train up a model to see, does the pattern of API calls that I'm seeing, those API sequences, do they make sense? Are they normal? So if you train your model well, it will attempt to follow those and do as best you can. It doesn't catch sort of new exploits as they go through that it hasn't been trained on, but it's doing a pretty good job of as long as the training is good. But the bottom line is that at best, these are educated guesses as to what the traffic looks like. So there's going to be some statistical false positives and false negatives that you're going to get. So as a result, both for rate limiting and for these kind of machine learning approaches, often companies choose to run these controls quite loosely because they're scared to death that they will hurt a customer's experience by falsely killing their traffic and not the other. So these are vitally important in the back end. They're good first line defense, but they're problematic because they're not perfect. So app attestation, I think, fills in some of this space and builds up trust. And as I said, I want to focus on 3 different areas. I want to assure that the API calls that you're going to evaluate in your backend are coming only from an authentic and untampered app, a real app, not a bot, not something impersonating that app. That app is running on a real and a safe device, that environment is not compromised, and that it's communicating over a secure channel so an attacker can't get in the middle of that device. So those are the aims we're going for, and I want to stress this does not replace any other defenses. This is in addition to, this is a defense in depth type approach. One other thing I wanted to mention, you often hear that what we need to do more today is shift left. We really need to focus on doing better testing of our APIs, on removing every vulnerability we can in APIs. Totally agree that we need to do that, but I think that's only half the piece. The operations side, the runtime side, you also need to invest in. So I would claim you need to shift left, yes, but you also need to shield to the right, move over into the operating space. So in an unattested environment, even a perfectly implemented API, if I can get a hold of your API keys or your user credentials, then I can abuse your API, even if you invest 100% of your effort in making that API totally vulnerable free as you implement it. So With an attested environment, I'm going to claim that even if your API is not perfect, even if there are some vulnerabilities internal into it, given that the only way those APIs should be callable, should be accepted by you, is if they're coming from a legitimate app, that means the only kind of API calls you should see are generated from the app itself. If I tamper with the app to try and do something, to hook something else, it will fail. If I do anything trying to exploit that API, it's going to fail. So even if there are some areas of your API, for instance, if you have some BOLA vulnerabilities, where if I can just hook a record with an ID, I can try a different ID and randomly try and see what I can find. Even if your API is not sensitized to block that, a regular app is not going to make that call. So I think it's really important to spend as much time and effort on the operations on the runtime side, establishing trust, as you are also trying to get all those vulnerabilities out of your API. Oops, did I get stuck? There we go. Okay, so a recommended attestation architecture. One, rather than a static secret, I'm going to adopt kind of the OAuth kind of model of using a time-limited, short time-limited token. So I'm going to take the static secret and use that to sign the token, which is then going to be passed with an API call that says, I have established trust and integrity in this solution. So because it's going to be short-lived, I would recommend just a couple minutes. Then you're going to be reattesting your environment and your device frequently. So that means that if somebody were somehow to get in the channel, all they're going to get is a short-lived, excuse me, a short-lived token, which they can exploit for a little bit if they can get their hands on it. Secondly, I'm going to pull that secret and that signing off the device into an external service. This is kind of analogous to how we do OAuth and user authorization. I'm going to create a service that's going to attest the environment that it's observing. It's going to hook into the running app by dropping an SDK into that app, which will give it the directions to enable it to walk through and look at the integrity within the device and the app itself. So now I've moved the secret off device. I get an additional pop for that because now that the secret's off for that, off device, if the secret gets somehow compromised, I can just change it in the service and I'm instantly off and running with a new secret. So real benefit to get that off, as well as all the security decisions I'm now going to be making off device. And it's a lot harder to hook something that's across and in another server somewhere. It's pretty much impossible to do that compared to using instrumentation frameworks to hook things that are going on in between. And so the only thing I'm going to add is analogous to the user authentication token checking is an additional backend check that's now going to check these short-lived tokens as well. So how do we do these sorts of things? Well, before you release an app to an app store or Play Store, you're going to register it with the service. It could be the Play Store itself if the Play Store is doing this type of attestation work, for example. Once it's registered, then the service has a sense of what the sort of DNA is of the application. It knows how to figure out what is an authentic app. So it will, when it will use the SDK, it will first do a check of the app itself to make sure that the app has in no way been tampered, that it has all its pieces and only all its pieces. So it's the real source code running untampered on the device. Then it's going to pivot to the runtime exploits and see what can it detect there. There's a whole range of things it's going after. Is the device rooted on Android, or is it jailbroken on iOS? Are there instrumentation frameworks running that are trying to cut in and do different things? Is this running in the debugger? Is it really an emulator that's running in a farm somewhere trying to pretend that it's an application? So a whole bunch of things, and they evolve daily. The runtime is kind of a cat and mouse game with people trying to continually introduce new exploits into that runtime system. On the channel side, we're not so much checking the integrity as we are trying to boost it and lock it down. So as I mentioned before, TLS is good, but in the mobile space, it's not perfect. Every device, and this would be the same for a web browser as well, has a notion of a trusted store of certificates. And when the app wants to connect to a service over here, it negotiates through TLS to find a certificate that would be presented by the service it's connecting to. And it would walk up a series of intermediate chains until it finds a rooted certificate that it already trusts in its device trust store. Good model, except that the trust store itself can be sort of broken into, and we can add additional trust items into that device global trust store. So if I'm a man in the middle guy and I want to get in between your system, I'm going to take my certificate, I'm going to inject it into your device store. And now when you're saying, hey, I'd like to talk to Joe's backend API service, the man in the middle replies with the certificate and says, that's who I am. We check the device trust store, bingo, we're in. So we're freely decrypting the traffic you work so hard to encrypt. We can take a look at it and easily re-encrypt it using just vanilla TLS to go through, so we can observe, we can manipulate. It's a great way to reverse engineer APIs and collect credentials. Very, very popular way to attack in the mobile space. How do you beat that? Is with a concept called certificate pinning. So here we take the actual certificate that we're expecting and we put it in sort of an application level trust store that's guarded within the SDK that's very heavily defended inside this application. So now we'll check the device trust store and say, well, okay, looks good so far, but what about the app level? Is there a pinned certificate there and are we matching it? So in this case, the device would say it's okay, but the application would say, no, this is not Joe's service because it didn't present the right certificate pin. One of the challenges with certificate pinning, however, is that certificates expire. And you've probably heard of situations where somebody's big service was down for a couple hours because all of a sudden a certificate pinned and essentially bricked the application. So this is a case where we have an advantage of having this remote attestation service off here. We can actually use that to manage the certificate pins here. So we can regularly rotate pins by sort of injecting them from that attestation channel in. We can observe it if there ever is a problem. You can go in there and generate new certificates and inject them into the system. Rolls out as each device attempts to attest, it's going to get the updated certificate pinning information. So it's a nice advantage of having this in place in that it solves a lot of the maintenance issues, which frankly have stopped quite a few people from actually implementing certificate pinning because they're scared to death they're going to brick their app. So what options do you have if you want to introduce attestation into your flow? Both Google with Android and Apple on iOS offer a flavor of attestation. Historically, they kind of started out checking the device level. Is this device, has it been tampered with, the device itself? And then they evolved towards checking some features of applications as well. So it doesn't cover everything, but it's a decent base. It can sometimes be a little bit slow. So you might not want to do it in a runtime environment. You might want to do some of these things when the app launches, for example. And it's not available in all markets. In Android, for example, if you don't have Google Play services, you don't get this capability. So if you're in a market that doesn't have that, you can't use this. And also, it's being introduced in newer OS versions. So some of these capabilities will not be in the older OS versions. So it's a good thing to look at and to use, but it's not universally useful at this point. You can go to independent packages. Sometimes these are keyed towards your mobile technology that you're using, the platforms that you're using. You can find root and jailbreak, for example, detectors. They're okay, but there's a constant battle going on. So they don't keep pace with what's going on quite often. But they're a good open source way to sort of dip your toe into it, but they certainly are not going to cover everything. I threw in package signature checkers there, so that's kind of a poor man's, has this app been tampered with? Does the signature look right as you go through? So you can start with those if you will. Commercial solutions, mine being one of them, and typically are trying to cover the whole spectrum, so they're broad and we're in the trenches fighting every day to keep evolving the capabilities. They cover not just the device and the app, but also the channel security. And as I said, man-in-the-middle type stuff is major attack vector that we have to defend against. We can optionally throw in safety net and device checks. So if you're in a market or running an OS that uses it, you can do that. And the advantages to this is that we will provide, any commercial solution should provide a uniform API. So using device check on iOS and safety net on Google, very different APIs, very different terminology, very different concepts. You can wrap all that into a uniform SDK, so you only have to do it kind of one time, and you let the vendor figure out how to make it all work. The last option, which I thought I would mention just to say don't do it, is roll your own. I talk to people, especially when they're focused on one particular technology, they believe, yeah, I can do some of this stuff myself, but they don't understand the investment that's required to keep pace with the hackers that are out there going on. As Francois mentioned, API attacks are super big, and with the leverage you have in mobile, is a frequent vector that hackers use to try and get into your system and look at the APIs, because there's just a lot you can do within this space. So please don't roll your own. Okay, what did I do? Okay, sorry about that. Okay, so we've got an attestation channel. I already mentioned there's at least one additional thing we can do, which is simplify certificate pinning management. What else could we possibly do with this off remote attester service that's sitting here? I'll just give you a few examples. One is that now you can make security changes on the fly. If this was baked into an application at the endpoint, you wouldn't be able to change security policies. A customer would install the app, it would say, we're going to block routing, and you're going to have to make that decision before you go to production. If you've got access to a remote service, you can make those kind of security policies on the fly. Retail vendors, for example, they don't want to at all touch customer experiences. So if a guy on a rooted phone pops in to buy something, you don't want to stop him until you find out that you're losing too much money because guys with rooted phones are somehow getting through and breaking through. So you want to be able to go to market one way and change your policies as you go through. So there should be a fine-grained ability to change those sort of things. You can also do things like, got to use the right terminology, accept listing and deny listing. So you can universally reject certain individual devices that you find objectable. You can add to the accept list any devices that, no matter how bad they look, just give them a token. And that would typically be used in, say, a testing environment where you just want to get this kind of work out of the way so you can focus on your functionality, for example. Another thing you can do is bind the user token you're using to these attestation tokens. So typically, the application token would take a hash of the token for user authorization and add it into the payload before it makes a signature. So at that point, if I have a random user credential and a random access token, before I could use them like cash, now I have to use them together and only together. So it's kind of like when you got on a plane to come here, you had to present your ticket, which had your name on it, and your driver's license or passport to prove who you are. So now they're locked together. So we're making it a little bit harder. You have to find exactly the right pair to go forward. Another thing you can do, I've been sort of assuming that you're in control of your back end. You use a really good proxy in the back end, so your app only talks to your API. In reality, on average, for an app, there's like 40 different APIs being called within an application that we see. That's a stunning number to me. Many of those are third-party apps, so you don't control the back end. The vendor is going to give you a key, and if you want to call that directly from your mobile app, not go through proxied through where you can control the back end, but if you want to call it directly, then there's that API key statically probably sitting in your code somewhere. What happens when the vendor just decides to change the API key? Do you have to roll out a whole new installation to all your users? So how do you protect that? So you can add the capability within this SDK to essentially allow you to call your API with some placeholder device. And when your networking stack sees that placeholder, it will reach out to the remote service and say, give me that API key. And it will rewrite that as it's walking through the networking stack. So now the API key is always stored off device. It appears momentarily in your runtime to be added to the API that goes through. So we're now calling third-party API keys. We're not sending a token to those third-party services, but instead we're sending it the API key we need. But that API key is not really appearing on your device where it can be exploited. Again, you have the ability to instantly change that API key. So you're, again, getting that benefit of that remote service. And then the last kind of trick you need to do is we talked about certificate pinning, but you can't necessarily pin a third-party API because you don't control that back-end service. But what you could do is kind of go the route of browsers, and you could pin all the standard browser trust routes that are there, which will cover everybody that wants to be reached. And you can put them in your app. So now, yes, they're in your device trust store. They could be compromised there, but they're not going to be compromised in the app protected within the SDK. So it would be great if I could sit here and tell you we can do exactly the same thing for web apps, but we can't, unfortunately, because the mobile operating system is grounded in some trust routes. The browser model, it does not give those same kind of guarantees. The browser model also does not have guarantees that you can inspect the code that is sitting within the browser. We throw JavaScript in and out of that browser all the time. It's very dynamic. It's very easy to get in there. There's not easy debugger detection capabilities. So a lot of the tools that we use in the mobile space are not really there on the web space. So what do you have to do? Well, the principle of kind of local measurement, grabbing everything you can find, still applies. And we see that most commonly in CAPTCHAs, the visible ones where you fill out the puzzle, as well as the invisible ones that are evaluating what they can in the browser. Typically, they're looking to gather whatever kind of contextual information. Is this an IP I recognize as being legit, or is it something that's not in my accept list? You can fingerprint the browser instances, trying to understand individual browsers and gathering some information and knowledge from that. You can often fall back on assessing what the human-computer interactions are going on. So if this is a browser on a cell phone, is it jiggling a little bit? Is the mouse being moved that looks like a human? And all the hackers are trying to emulate in their bots that same kind of motion. So there's, again, another one of those back and forth games that goes on. And you can carefully try and tighten those back-end controls you have in place, but you're usually scared to death of harming a customer's experience. So it's a tough trade-off. So this is a difficult environment to do well. It's probably constantly evolving. Maybe we'll see some work in improving formal attestation within the browser space. I'm not seeing it happen anytime soon. So I hope I've convinced you why you should consider client attestation. It provides this runtime integrity that's missing, including the app, the device, and the channel to your backend API. It's fairly easy to introduce. In addition to the runtime integrity, it also gives you a lot of runtime agility. We talked about switching in and out API keys on the fly without too much difficulty, for example. It inhibits API abuse, even when you don't have a perfect API implementation. So by restricting your API calls to only legitimate apps in a safe environment, you're not going to see some of those widely exploitive type calls getting through. And one thing I didn't really touch on is it's going to help block API reverse engineering. One of the biggest ways is just blocking man in the middle. When I am given the task of trying to understand your API so I can start to figure out how to exploit it, that's where I go first. I just want to get some traces of your API calls, see where the credentials go, see how things are going, throw that in some fuzzing, see what I can do. So if you can't get into that channel in the mobile space, then I can't get access to my favorite tool to go through. So if you can't reverse engineer the API, even if you're not using all these tricks, it's a lot harder for me to try and impersonate legitimate API traffic. So I hope you'll consider adding these kind of tools and filling out this model of everything between the user and the backend and establishing trust in that whole space and add it to your toolkit. Thanks for your time.
Thank you very much. So thank you guys for joining us this morning. We have another couple hours this afternoon. We have Dan's going to be talking about API resiliency. We have Gary calling in from the UK to be talking about emerging patterns with gateways. And then Bala's going to finish the day with emerging strategies around API gateways. So in the meantime, it is lunchtime. So there are 5 different, there might be more, different buffet areas. One right out here, one all the way down, and several downstairs. Feel free to hit the Partner Pavilion. That's where you'll find a lot of your favorite vendors, such as Broadcom Software, if you want to stop by and find out anything more about Broadcom. And with that, we'll see you at 1:40 local time. Thank you.
Hi, everyone. My name is Daniel Gaudet. I'm actually an API Academy member. Today, we're going to be covering improving API resiliency using API gateways. And sorry, there was a bit of technical difficulty, so we're starting this session again. So what's the topic? What we're going to start about in terms of agenda? We're going to say and review what is resiliency. Why do we need to have resiliency? And then since we're talking about API gateways, it's good to have a good understanding what API gateways are. I'm going to do a short overview as well as provide an example architecture. Then we're going to jump into the meat of this session, which is going to be API gateway patterns that help improve stability, or in essence, resiliency. And then we'll have a summary of what we covered. So where do we get a definition for resiliency? Well, let's take from a dictionary. Merriam-Webster has a definition of which they say, resiliency is an ability to recover from or adjust easily to adversity or change. Now, the word adversity might need a little bit more definition, and easily, Merriam-Webster comes to the rescue. We also have the definition of adversity, which is a state or instance of serious or continued difficulty or misfortune. So when we put the two together, we have a definition of resiliency that's an ability to recover from or adjust easily to a state or instance of serious or continued difficulty or misfortune. Now, when you talk about API communication, it's the ability to recover and adjust to really misfortune or difficult situations where, in terms of its access, it's still available, it's still working, still doing what it's supposed to do. But turning it to the other direction in terms of clients, so API developers, API consumers, what does it mean for them when you're resilient? Well, in their perspective, it's all about stability. It's always available. So unbeknownst to them, there's been any problems. So resilient system provides stability. Insofar as when you consume these APIs, they are going to be available. They are resilient. So why do we need resiliency, right? Why is that important? Well, from a technical perspective, I'm going to leverage some quotes from Michael Nygaard in his book, Release It, which I use every day when I talk to my customers in terms of API resiliency, API stability. So he talks about the fact that, and we can all agree with this, things happen in production. Bad things you can't always predict. On top of that, bugs will happen. They can't be eliminated, so they must be survived instead. So that's why we want to look at resiliency from a technical perspective. Now, on the business side, what does it mean, right? Lack of resiliency means downtime. And what's the cost of that downtime? Well, productivity losses. Imagine you don't have access to services, to systems, your employees are stuck, they can't do any work. You're losing productivity, right? So at the heart of these systems are APIs. And if those APIs are not available or are in a state of air condition, you're going to have productivity losses. But if these APIs also help do business transactions to move the business forward, you might actually have lost sales opportunity in terms of a website selling widgets or something. Or if it's your core business that you're actually generating revenue with your APIs, those are possibly missed opportunities. Now, on top of that, though, let's say that someone's using your mobile app, or there's some kind of API that's being leveraged by consumers out there. It can also damage the brand. Maybe it might make your brand seem like it's just not reliable, right? Because the business runs on APIs these days. So when you have lack of resiliency, downtime, your brand is damaged. Now, on top of that, you might actually be providing API services to other external organizations, and those would have service level agreements. So if you have some kind of downtime or where those APIs are not available, not performing up to spec, You could also have additional financial penalties as it comes to service level agreements. And then lastly, you could also have data loss, right? So when these APIs can't communicate, let's say that systems come down when you're doing this API communication, you could actually lose data. There could be something that in transit that just doesn't get captured again. So those are all risks. There's definitely more, but these are the top 5 that we tend to talk about with a lot of the people that I consult with. So taking that into hand and then looking at how to make APIs more resilient, we're looking at API gateways. So what are API gateways? Well, first and foremost, they're a form of proxy, right? But specifically, they're a layer 7 proxy. What does that mean? Well, they work at the application layer. So, mostly in today's conversation today is going to be mostly about synchronous APIs. I will talk a little bit about asynchronous towards the end. But when we're talking about API gateways, it's mostly about synchronous HTTP or HTTPS type of traffic. And these layer 7 proxies, API gateways, act as an API front end, forwarding requests going to backend services, mostly APIs and web services. But it could be other protocols, like a queue, it could be a database, could be to some other systems. It also helps enforce policies. So security policies, governance policies, making sure that what comes in follows regulatory requirements, maybe security policy in your organization. It goes through a whole set of rigorous checks and bounds. And on top of that, when you start looking at orchestration, it can start making multiple calls to different systems. And when you put the two together, for example, having the API gateway talk to some rules engine or other validation systems or an LDAP or database to actually make sure that what happens is correct, it becomes an enforcement point on top of that. So it's very flexible. It's usually more advanced than your average proxy. Now, you keep in mind that a lot of web proxies can also be considered at a very fundamental level an API gateway. But the ones that I'll be focused on today, though, can do a bit more. They can do enforcement policies and orchestration. It can also do protocol bridging. So they don't just talk about HTTP and HTTPS. They can talk JMS. They can talk FTP, SSH, different types of queuing systems other than JMS. So they actually bridge different protocols. Or they can do HTTP2 to HTTP 1.x or vice versa. So they really help bridge that. But they can also bridge things like security contexts. Maybe you've got OAuth 2 in the front, SAML in the back, or basic auth. They also do that kind of bridging as well. But most importantly into this, for API gateways, is that it has full visibility into the requests and responses, which is critical when you're doing some kind of resiliency. You need to know what's going on. You need to have a bit of intelligence in terms of what's going on there. And that's where sometimes some of these other proxies might not necessarily fit the bill to what I'm talking about today, right? So having that full visibility into the payload, the HTTP headers, and additional meta information, requesting IP addresses, where it's going. So it's got full visibility. In essence, actually, API gateways have N+1 visibility because it sees who's coming in, it sees where it's going, as well as the responses. So it can actually give you a good heartbeat to what's going on. And it's also not a bad place to do some tracing as well. But that's not necessarily coverage we're going to do today here as it relates to API gateways and resiliency. Here's an example deployment where we can see where API gateways go, right? So usually, and in cloud environments, there might not necessarily be a DMZ per se, and it's just everything's a trusted zone. But conceptually, what's important here is that you can see there's different API gateways here, and they can connect internal systems and external systems. And every communication goes through an API gateway, right? And what's interesting here, you're seeing all these lines on the left and on the right. And actually what we call that is a butterfly pattern, right? So why is that important? Well, Michael Nygaard in his book, Release It, he talks about the fact that connections actually, this integration is an anti-pattern to resiliency. Ideally, if you had no connections, you'd have a real resilient system, except probably of no use to you because it wouldn't be on any networks. So there has to be a balancing act here. So when you start to connect different things, this butterfly pattern is actually pretty good because it limits the number of connections. Usually you start to 2n number of connections because you have something coming in, something going out. So you have 2 connections, and then it can be more. When you start to do orchestration, you might have a few more API calls, but it's not exponential, right? That's something that's important here. Now, I will say that when you have this kind of architecture, it does mean that you have a system with a lot of responsibility because you're literally putting all the traffic through this. But nothing stops you from having separate environments. We'll talk about it a little bit later. But what's key here is communication going through these API gateways. Now, what's the opposite of that? Well, then you have something called a spider web pattern. So when everything talks to everything. Nothing wrong with that conceptually in terms of, if I've got all this flexibility, all these systems can talk to each other, as a developer, I don't need to worry because now everything just seems to work. Except there's a problem here, right? This can have up to 2 to the power of n connections, right? So now you have exponential growth of number of connections. Now, this is extreme. We don't tend to see this. Usually when you do deployments, it's something in between these two. But it's a lot more difficult to provide resiliency when you have all these connections. Now, you could have something in between where it leans more towards the 2 times n, right? Where you actually don't have as many connections, but sometimes you do have some systems talking to each other. But keep in mind that the more connections you've got, the less easily it'll be to provide resiliency or stability, in other words. So what are we going to talk about today? How do we increase resiliency? Do we just do the butterfly pattern? That seems to solve all our problems, but not really. It's just one of many things, right? So yes, you want to have as few connections as possible, but sometimes within your business processes, you do need to have systems that talk to other systems. That's the benefit you get through this environment, right? So what do we do then? We actually apply stability patterns. So we have a happy medium. So we try to be as much towards that butterfly pattern, right? Not the spider pattern, but then within what we do is we start to apply some of these stability patterns. And actually all these are discussed also in the same book I mentioned earlier by Michael Nygaard, the Release It book. And I've taken a few of these. I've taken 6 of these to talk about today. So with that, there's going to be the timeout, circuit breaker, bulkhead, fail fast, handshaking, and decoupled middleware. And I'll be covering all of these today in today's session. So first things first, the timeout pattern, right? What does that mean? Well, imagine you've got a system that you're talking to back an API, and in this case, we do have an API gateway, but there could not be one as well. And by default, a lot of systems, internal systems, will have a timeout of 60 seconds. So let's say this API, for whatever reason, we don't know why, cannot respond. We're going to put a request in and wait 60 seconds. Now, some browsers or some APIs will wait 30 seconds or maybe 2 minutes. But in this case, let's assume that it's 60 seconds. So for 60 seconds, the system's not doing anything. It's just waiting and waiting and waiting. Now, if it was only one call, well, end user experience is not great, but it's not a big deal. Let's imagine, though, that there's 300 of these going on every second. So we're talking 300 requests a second. And let's say that each one of them is going to take 60 seconds to time out. After 60 seconds, we're going to have 18,000 concurrent connections all of a sudden. Can this API even withstand that many API calls? Maybe, maybe not. You could say, well, we have a cloud-native environment that can just scale out. Here's my credit card, just keep scaling out the environment. That usually doesn't work, right? There's a cost to that. So what we're talking about here is actually reducing the default timeouts to something more manageable, to 5 seconds. And now some people might say, 60 seconds, 5 seconds. I've got customers that I've worked with that actually have 300 seconds for timeouts, right? And that problem just exacerbates. Like it just gets bigger and bigger and bigger. You really have to be careful when you have these long timeout values. It really doesn't work well in environments. Oh, there's a question?
So, do you mind if I...
No, I don't mind. Just gonna
Oh, yes.
give you the microphone because we're also live streaming.
Oh, okay. So my question was that what if we put a load balancer between API gateway and the no response condition thing? So that way we can just figure out that the API thing wouldn't get 18,000 requests in a second, right? The load balancer thing will divide the request. So,
And that's a valid question. And usually there is a load balancer in the front and in the back. But imagine behind here there's a single database cluster. It's still going to get 18,000 requests and maybe even more. But you're right. In terms of layer 3, we can start to help minimize that problem. But you're still dealing with 18,000 connections. I actually have a case where I worked with a customer where they had 3,000 agents logged in at the same time. And unbeknownst to this particular customer, their single-page app did 26 concurrent calls. And you can say, well, browsers aren't allowed to do that. Well, the API gateway had at least 30 different names. So it was the same API gateway, but with 30 different names for different APIs. So every time someone would make a call, it would actually generate 26 concurrent calls at the same time with a 60-second timeout value. And the backend environment was getting all these calls. Now, there could actually be up to 9,000 agents at the same time, but just let's go with the 3,000. Imagine having 3,000 requests coming in with, 3,000 clients logging in and using something with a timeout of 60 seconds and is making 26 API calls at the same time concurrently. That's 78,000 calls. Now, this particular customer, their load balancer could only handle 50,000 calls. What do you think happened? Everything just went down. Because now the load balancer, and when it went down, every other communication went down too. Like it wasn't just this system, it's everything else that the load balancer had. So absolutely, like taking a defense in depth approach, load balancer can help. But then there's more to it than that, right? So you had developers in this particular case that were told make the app as responsive as possible. So they had the smart idea of saying, let's do 26 concurrent calls because it's the most responsive. And internally, that's what they did. The actual business owner thought there were 3 business transactions, and that's what they designed the system for, not 26 API calls, right? Behind the scenes. Lesson learned, right? But the thing is, when you're starting to build this, you want to have a system where you can't just say, because that's what they assumed, the load balancer, that's exactly what they assumed, was a load balancer can take care of everything. And in this particular case, they could only do 50,000 concurrent connections. Now, some load balancer can do more, but just keep in mind that this is only for over 60 seconds. What happens in the back end? Well, the front end users kept clicking reload, 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 and reload. So it was always 78,000 plus connections all the time, right? And sometimes they open up an incognito browser and then double the load from that one workstation, even making it worse, right? So the secret here, though, or the answer ends up being have very low timeout values. You know, imagine bringing it down to 500. Right, to 5 seconds, sorry, not 500. So we bring it down to 5 seconds, you have a very different scenario, right? So in this case where we had 3,000 clients, that means 15,000 connections, and then they time out.
But then, can we put a rate limit thing out there?
So you're asking if we can add a rate limit, and those are some of the other patterns. So we're going to talk about some of the other patterns in terms of, but in this case here, let's say that, again, we don't know why this is not responding. We don't care. So one thing we want to be careful is we don't want to tightly integrate this to that. The API gateway needs to know what it's doing. Now, there's going to be another pattern we'll talk about called handshaking, where we do health checks. And that's going to help with that. And this way you can implement things like rate limits as well. And absolutely, rate limits can help. And you can put those in place. And they do help in terms of request responses. But businesses want to be careful. If, in this one case for this customer I talked about, this is their #1 system generating revenue generation system. They didn't want to put any rate limits, right? They didn't want to have less sales. They thought load balancer and everything will take care of everything by itself. We actually changed it to 5 seconds and everything resolved the problem, just to put it in perspective. So in the end, changing it to 5 seconds solved the problem temporarily. Then they went back and redesigned the app so we wouldn't do 26 concurrent calls, right? Actually, similar situation, there's actually another company that has a Visio, I'm not going to mention any names, a Visio competitor for online, doing some diagrams. They went from HTTP 1 to HTTP 2 on some of their systems because in the end, there was only one concurrent connection. What happened after that? Well, they said their load and system slowed down because the same thing I just told you about this other example happened with HTTP 2. It became very, very, very spiky. And the spikes were way higher because it was HTTP 1. A browser only does up to 6 concurrent connections usually. This was doing 100 concurrent connections. And then the system could not handle that. So again, timeouts are critical to help provide some stability. And the short of it is stop waiting. Just after 5 seconds, you just cut. Don't worry about it. But it's like a dumb, like just let's not think about it. That's the first pattern. The second pattern is circuit breaker. So let's say we have something similar to what I talked about before, and we have an API that works, everything's going good, and that's called a happy path, right? So it's a closed circuit breaker, like a power supply or a circuit breaker for your house, your home, or a fuse. So when everything's working fine, there's no problems, but when you open the circuit breaker, you have some kind of error condition. And instead of talking to this API, you either talk to a cache or a static response. You still provide some kind of response though, right? It's not a timeout. there could still be an error, like a 529, for example, but there's at least something here. The gateway still responds. The front-end client gets some response. Okay, that's in terms of an open circuit breaker. Now, it works well, actually, with a timeout pattern. So if this thing gives out, then we can always at least provide something. And the lower the timeout value, the better this is. You know, if you were to say it's a half-second timeout, then end user experience will be a lot better than waiting 5 seconds, right? So keep that in mind. And in terms of how do we turn it on again? Well, then we have a half open circuit breaker. So we do a little bit, either one or a few calls to see, is it still available, right? Or we can do the handshake pattern we'll talk about shortly, right? But is it working or not? And if it is, then we go back to having the closed circuit and you're back on track. I know I'm running a little bit low on time here, so I'm going to have to go a little bit faster. So the next pattern is the bulkhead pattern. And in terms of bulkhead, think about a ship or a boat, right? Where we have different bulkheads that if you ever have some kind of collision or something where water comes in, you minimize the impact. You contain the damage or the impact. So this is an example of a ship where you can see all of these bulkheads. So if there's any kind of damage, water only goes in one place and the boat doesn't sink, or at least gives you enough time to deal with the problem, right? So when we're talking about that with API gateways, there's many, many ways to look at bulkhead patterns. So bulkhead patterns could be, I want to have 2 separate racks of servers, separate VMs. When we're talking about API gateways, we're talking about having different channels, either for different listener pools, right? Maybe I've got a fast lane, slow lane, because remember before we were talking about API calls, and to have something that takes 60 seconds to respond is not good for performance, and it eats up a lot of resources. So I actually have customers that I work with where they have what's called a slow lane and fast lane. Dedicated resources, dedicated path for slow lanes, which because then you start to accumulate a lot of calls, but you limit that pool to small numbers. You can't have too many of those going on at the same time. And then the rest of your traffic goes through there, where that would be the fast lane. The gateway, because it's got full visibility in terms of those payloads, it can make a decision. Do I go here or do I go there? Or it could be based on endpoints. It could be based on method calls. And it could even be made, I'm doing a bank transaction, and if it's a $1,000 transaction, you go here. If it's a $3,000 transaction or more, you go there. So you can do that with the bulkhead pattern. You can also do it for business critical processes. But in essence, you're doing dynamic routing and you're limiting the impact. So if this, in the backend, let's say the backend here crashes. So let's say you're doing a place where you're doing queries where you get lists and you can actually do some transactions. Well, maybe, nice to have is, I want to get additional details on items. Well, maybe that one gets dropped and you just do the business critical functions on the other one. So that's the bulkhead pattern. The gateway is very well placed to do that. It doesn't necessarily hit the backend APIs if it doesn't need to. Remember, when we're talking about this, we also talk about failure, right? So let's say earlier we're talking about timeout patterns. That means we actually made a call to see if something worked. Well, what if we already know it's down? Well, that's called the fail fast pattern. We don't even process the request, or at least it never makes it to the back end or to the front end. So let's say that from a front end perspective, well, actually, let's go here. So let's say from a back end, this is got some kind of error condition, maybe the timeout, maybe some other reasons. Well, if the gateway already knows this, the request comes in, we're just going to fail it. Because why even bother doing the 5-second timeout if we know it's not going to work? But it also works well if you have the circuit breaker pattern as well. And on top of that, what about front-end clients, right? I'm going to put an invalid API or invalid characters. Well, never make, some systems will actually make the backend call and do all that stuff. Even though it's an invalid request, comes to the gateway with an error, and then we error out. Why bother making this call? Even though the service was right, this had an invalid input, right? Either non-compliant requests, maybe characters, maybe someone's trying to hack me. Who knows, right? Maybe it wasn't authenticated, authorized correctly. Maybe this person or this particular request wasn't allowed to do this. Don't bother making other requests. Now you can say, well, that seems like it makes a lot of sense. The reality is a lot of systems will make the call anyways first and then error it out. Fail fast. Don't bother with it, right? So in the end, decide to stop processing the request. So with that, I was talking about this a few times, this handshaking pattern. So this is where we can do things like throttling. We were talking about API calls and API rate limits. This is where we do handshaking in terms of the gateway can implement some kind of throttling. And this can be on many, many different levels, right? In this case here, I've got an example where we're doing health check probes. Are these systems available? Yes, no. And maybe since I'm also aware of all calls going back in and out, I can have an assessment that things are getting kind of tight. I need to limit and maybe do dynamic throttling, for example. Maybe these, and let's say that the health check probe fails. Then you look at things like the other patterns I talked about before, like a circuit breaker or fail fast, right? So you start to look at having and multiplying these different patterns. And by the way, I want to make sure it's not the goal to have as many of these patterns on, right? It's not, oh, I've got 10 of these or 6 of those. That's not the premise here. You use what you need for your particular environment in your particular cases. But you can see how they can work well together, right? In this case here, we're going to look at keep alive. So just like timeouts, when you negotiate a connection, you can also keep alive the connections. So it's not a question of I'm doing anything. There's not a timeout. But again, I've had other customers where the keep alive caused problems. Because maybe I've got a very chatty application, but it's only every 2-3 minutes. But it's going to keep the connection open for 60 seconds. Bring that down to 5 seconds, right? And then you'll again see that you're going to get more resources because nothing's free. You need more I/O, you need more memory. Like all those things take time and resources. So do things like negotiate a lower keep alive or keep alive timeout as well. And that's both for the backend APIs as well as the clients connecting to the gateway. You negotiated both spots. And the last pattern we're going to talk about today is the decoupled middleware pattern as well as an architecture. So this is a bit of a difference. This is where we use something like a queuing system. Now you're going to say, well, what do you mean by queuing? Well, the reality is sometimes when you're doing web traffic, it's all synchronous. I click something and I get a response. If my backend gets to be slower, everything gets to be slower. The case here is that I go very quickly back and forth with the client, with the gateway. Request comes in, gateway goes and puts it in a queue. Now, the thing is, this is and can be a major architecture change. So usually you want to bring this in earlier. All the other patterns I talked about, you can incorporate usually today without any major impacts to your environments. This one here requires usually a rethink, especially in this end, on the client side, because how does it know when it needs to look at it, right? So we've worked with customers where this provided a 10x increase in availability and performance because the backend systems went at its own rate through a queue, and when it was finished doing its work, puts it back in a second queue. Gateway puts it into its own system in a cache, and then this system makes a query. Now, the front-end client, for example, in this case, one of the examples I'm working with, it would make a call every 5 to 10 seconds. Are you ready? And sometimes we'd say, wait another 15 seconds or 20 seconds, and we'd increase that. But these are very quick 10 millisecond calls, whereas in the past, these were taking up to 60 seconds. And see how the resource is. So this is a very strong architecture pattern, but it requires a bit of work and a bit of knowledge to help work with this. So, and again, the API gateways can definitely help with this. So to summarize, we talked about resiliency really is about stability. And we talked about 6 different patterns where API gateways can help make your APIs more resilient today by covering these 6 different patterns as well. Well, this is also an architecture as well. The timeout, which is all about stop waiting, just short, a lot faster. Circuit breaker, where we reroute during some kind of failure. Bulkhead, it's all about damage containment. Fail fast, where we decide to stop processing, right? We know it's not going to work. Handshaking in terms of health check, negotiations, right? Just make sure we know the systems aren't available. Or maybe put things like keep alive or some kind of negotiations or rate limits in terms of number of requests for that particular connection. And then the decoupled middleware, where you're really putting from synchronous front end to an asynchronous back end. And with that, that's my short, quick overview. Thank you very much. I think that's all I had for time.
Thank you very much. Appreciate it. What we're going to do is give us about 30 to 60 seconds to make a transfer to a mobile or a remote presenter.
Yeah.
And we'll go in right away.
Yes. And release it?
Release it.
Yes. And I'll put it back on that page just for a moment. And that's Michael Nygaard. And this is the 2nd edition. And that also, I should say, this also applies to building microservices or APIs. If all of the systems, including API gateways, follow this, then you will have more resilient systems. The problem is, it's more difficult to re-engineer that in your API. So putting in the API gateway is a very good place to start and provide resiliency. You're quite welcome.
Thanks. Hey, so I'm Gary from Mullen. I'm also part of the API Academy team and the Broadcom Layer 7 engineering architecture team. So today I'm going to give you a brief introduction to Kubernetes operators and how the Layer 7 operator will allow us to reshape the deployment, maintenance, and resiliency of Layer 7 API gateway deployments in Kubernetes. We have a couple of slides to get through, and then we'll head into a quick demo of our operator in action. So all of the information on the screen here, with the exception of this diagram on the right, can be found on the link in the top right. If you aren't familiar with Kubernetes operators, then kubernetes.io is a great place to get started. There's also a wealth of really great resources out there that you'll be able to find as well. So in a nutshell, Kubernetes is great at managing applications and deployments, but it doesn't have domain-specific knowledge or expertise about applications or services like the Layer 7 API gateway. And that leaves more complex tasks and processes to manual intervention or custom scripts, workflows, jobs, and that can become really cumbersome and exceedingly hard to maintain over longer or sustained periods of time as you have people joining your organization, moving away to different teams and leaving and so on. So instead of customizing or modifying the core Kubernetes code, operators allow us to extend the functionality of Kubernetes using custom resources and the control loop. So in that, operators are software extensions to Kubernetes. And that gives us a way to take domain-specific knowledge and expertise of a human operator or a vendor and write code to automate tasks that would otherwise be manual. And that takes a lot of the guesswork out of how to deploy your application into Kubernetes, how to upgrade it, maintain it, test it. And all of that leads to flattening the learning curve, which gives you more time to focus on actually using an application versus trying to figure out how to do all of that stuff from documentation and so on. And that allows you to get the maximum value out of it. So one thing to mention as well is, yes, today I'll be introducing the Layer 7 operator. The Layer 7 operator is built using the Operator SDK, which is a standard method for building operators in Kubernetes. So the flows and so on that I'll be introducing today are quite generic and are things that are going to apply to most operators that you'll see out there from other vendors and so on. So the diagram on the right here I have is a very basic depiction of the control loop that Kubernetes operators use to manage applications. We have very simply observe, analyze, and act. So this all starts with, let's say you want to deploy an application into Kubernetes. You're going to define a desired state in the form of a bunch of configuration files. So you'll have something like a deployment file. You might have a service because you want to expose your application to an external or an internal audience. And you might also have a config map and some secrets for additional configuration that you want to go into your application. So you're going to take that desired state. You're going to send that into Kubernetes. Kubernetes is going to observe that, hey, I've got some configuration that I need to take care of. It's going to analyze it. Does your desired state match reality? And if it doesn't, then Kubernetes is going to act by instantiating your application or updating your application in Kubernetes and making that available. So with the Layer 7 operator, this is a 50,000-foot view of the kind of the basics and the overall that you get with it. I'll break this down into the different flows that we might. I'll break this down into one of the flows that we might have from an operations perspective, or from a developer that wants to have a gateway or deploy a gateway. And as mentioned, this is something that's going to apply to most operators built using the Operator SDK, which is one of the standard patterns for doing so. So we might have someone in the operations team or someone in a development team that wants to have a gateway up and running. The way that they're going to do that, the way that they're going to define that desired state is by creating a gateway custom resource. So gateway custom resources is something that the Layer 7 operator manages. That's going to go to our Layer 7 operator. It's going to kick off the control loop or the reconcile loop or the reconcile function. Layer 7 operator is going to observe, hey, I've got this configuration here. It's going to analyze it. Does desired state match the reality that I want or the reality that's running in the cluster? And if it doesn't, in our case today, it's not going to, the Layer 7 operator is going to act by instantiating not only the gateway deployment, but it's also going to take on the service that we're going to use to access our gateway. It's going to look at additional configuration, like do we want to have a load balancer there? Do we want to, or do we want to go through an Ingress resource to access services? So something else that we might want to do from an option, so something would be optional is having a management service. So we want to make sure that all of our management functions, if we do have any for application, are only exposed internally to internal tool chains and CI/CD pipelines. So we can also create a management service that's going to be locked to an internal port and be available internally only, that developers can interface with. Some of the other things that we have from our operators' perspective, the first is horizontal pod autoscalers, or HPAs. Autoscaling is something that Kubernetes gives us for free. So that's a configuration that we make available in our gateway cluster resource. And that's something that we'll also take a look at the cluster resource and see some of the configuration in that as well. The Layer 7 API gateway uses MySQL database to maintain persistence. In the demo today, we're not going to be configuring that. We also have a shared memory data store that we use called Hazelcast. We're not going to be configuring that either. But any additional configuration that you might want to have, or external systems that you need to connect out to, would all be configurable from the custom resource perspective. So you wouldn't have to have additional configuration for other things that you want to connect into. An operator is going to take your configuration and make everything a reality. The other thing that we have, and what we'll be using today for our demo, is a policy repository. So that's just a Git repository. It's got a file that it has a configuration file that the gateway understands. So that's going to be configuration as code from the repository. It's a very, very simple policy that's just going to give us back a hello world endpoint, and that's going to be configured. In the gateway custom resource as well for us. And we'll also take a look at how that gets applied and sort of what the end result of that is as well. So just a quick overview of what we've just discussed, and then also a note on install mode, which are quite important for operators. So the managed custom resource that we'll be focusing on today is Gateway. Currently, that's the only custom resource that we manage as kind of an alpha release of this product. In the future, we would look to cover additional products as well. So something else that we have is a set of API management Helm charts that cover our portfolio. We wanted to get at least feature parity with our Gateway Helm chart, so that if you're moving between the two deployment methods, then you're going to get a similar experience across both. And the rest of the features here are things that we've already discussed. So the dedicated management service, optionally, if you want to hook in existing tool chains for CI/CD processes. That Git integration, which we'll look at, autoscaling, which we get for free, and a fair amount more. So in terms of install modes, the default or the recommended way to install operators in Kubernetes, not just the Layer 7 operator, is going to be own namespace. So for own namespace, basically the operator is going to be able to manage everything. That it needs to lock down to the namespace that it's deployed into. The reason that this is important is because operators also manage other things, like config maps, deployments, secrets, stateful sets, and so on in Kubernetes. And so if you have an operator deployed in all namespaces, you would be able to configure the operator to only watch a certain set of namespaces, but that could potentially be a problem if you don't necessarily trust the operator that you're deploying, or if there's an update that you don't feel hasn't been tested properly, or something along those lines. It's going to be a better option to deploy it in its own namespace with that method, and have everything restricted to a singular place. And for the demo today, we're going to be deploying it into own namespace, and that namespace is going to be aptly named Layer 7. So if there's no questions, I'm not sure if there's any questions. Otherwise, I'll move straight into the demonstration. Okay. So I guess the first thing that I'll show is the actual Layer 7 operator itself, Layer 7 operator repository itself. This is going to be very similar to what you would get with a base project from an operator SDK. So the structure is going to be much the same, and it's going to be much the same going to different operators. So as mentioned, the idea with an operator is to take all of the deployment, management, fault finding, troubleshooting, and so on, and take that into almost a managed service managed by the operator in code. The bundle repo, or the additional Git repo that we're looking at today, is just this one here. We have a very simple bundle file that the gateway is going to understand. That's going to create a hello world service onto our gateway. We're not going to touch anything. We're not going to touch anything here. The layer 7 operator is going to connect our gateway into the right place and make sure that's available when the gateway starts up. So configuration is code, and relying on Git as a source of truth. And there's obviously additional things that we could do with that, but for the time being, we're keeping the Git integration relatively straightforward and simple. So the first thing that we'll need to do in this environment is actually deploy the operator. To do that, we don't need to download the entire code repository. All we need to do is have this bundle file. I mentioned that we'll be doing an own namespace installation or deployment, so we're just going to need that bundle file there. That contains the custom resource definition. It contains the operator deployments, and it also contains the role-based access control that we're going to need, the roles and the role bindings that we're going to need to do this. If you wanted to deploy your operator in a cluster-wide fashion, then you would go you would go with the cluster-wide bundle, and that would include all of the cluster-wide roles and so on, which is a bit more dangerous. It's going to create roles, cluster-wide roles in your Kubernetes cluster that's going to have access to probably more than you want them to. So from a security standpoint and from a separation of concern standpoint, the standard own namespace installation path is going to generally be a better option. So to do that, all we're going to run is kubectl apply -f, and we'll go to that deploy operator folder, and we'll deploy the bundle.yaml. This is going to create a bunch of stuff from us, as I mentioned. That bundle file contains the CRD, the operator, and the RBAC stuff. If we run kubectl get all now, we should see some stuff coming up. So that stuff's still being created. Yeah. So you can see we've got the layer 7 operator starting up. We've got a service. For that internally, and we've got that deployment as well. So the next thing that we would want to do is actually deploy a gateway custom resource. So as part of the installation, we also installed a custom resource definition for the gateway. So if we now do kubectl get gateway, then we're currently going to have no gateways available in this layer 7 namespace. So to deploy that, we'll deploy it, and then we'll take a look at the configuration. So for that, we're going to use customize. So kubectl -k for customize, and we're going to pass it the gateway folder. I've got to apply. And that's now being created. So if we now do a kubectl and we get our deployments, then we can see we've got our layer 7 operator, and we've also got ephemeral SSG, which is the custom resource of type gateway that we have created. So that's going to be ready soon. Let's quickly look at the configuration. So in this configuration, we have our own custom API version that is part of our custom resource definition. One of the things that our operator manages, and we've got a resource of type gateway. So I'm not defining a bunch of different files with different configuration. I'm defining one file that contains everything that the operator needs to instantiate my gateway deployment in Kubernetes. I've got some very basic things here, like where the image, like which image I should use, and if I have a repository that requires authentication. And I've also got stuff like the service account name and so on. By default, we have autoscaling enabled, so we should have 2 replicas running shortly. And something else to note here is that we don't have any authentication information in this custom resource. So everything is going to be defined up front. In the example folder that we have here, we have some of the files that are going to be required to do that. The idea being that those would be created beforehand or during deployment, but they wouldn't form part of this gateway resource. We have the Git integration here, so we have repository enabled. That's going to connect into the layer 7 bundle repo that we talked about earlier, and it's going to make sure that the stuff in that bundles folder is available in our gateways. We've also got we've also got some of the basic stuff that you can do with Kubernetes deployments. You can add init containers, you can add sidecars, you can add additional volumes, anything that you want available on the gateway or available on your gateway deployments, you can define through this custom resource. And you've got additional information that you can define around management, how you want the gateway service to be exposed, whether that's a load balancer, whether that's through an Ingress resource. So for today, we just have this going through an Ingress resource. So now that we've created the gateway, we should be able to see that we've got ephemeral SSG. We can see we have that deployment created. So if I get that and I output in YAML, I output that in YAML, we can see we have everything that we defined in this file. And I can also see I've got something in status, which is a commit ID. So that's the latest commit ID that I've got on my on the layer 7 bundle repo. If that commit ID changes, then the operator is going to pick that up, and it's going to automatically make sure that the desired state of my repository is going to match whatever I'm running on my API gateway. So that's one. That's one use of using that control loop to constantly make sure that the gateway is running as expected. And there's additional things that we can do here as well. So it could be making sure that testing and stuff works as expected, and so on. So the last thing that we'll do is just hit that hello world service that we spoke about. So we can go to the gateway's endpoint, and we'll simply just type in hello world there. It helps if I spell hello world correctly. And we can see we've got a response there of hello world. So very, very simple. If I then want to remove everything, all I've got to do is kubectl delete -k, and I can delete the gateway. And if I go back to my deployments, I can see that that's been deleted. So in summary, I've given you a very brief introduction to Kubernetes operators, a very brief introduction to the layer 7 operator, some of the value that you can get from using operators in Kubernetes, and also a quick word on the best way to install them from a namespace perspective. Thank you.
And we're going to do a quick swap over, and
hello all, thanks for coming. I'm Balaji Radhakrishnan, Senior Solution Architect from Broadcom Software. As per agenda in this session, we'll be discussing how API Gateway is going to handle a revoked token condition using continuous access evaluation protocol, followed by a component architecture where this use case will be discussed in detail, and then the sequence flow. And finally, solution deployment demonstration of the solution for this use case. So in today's modern world, there are certain things I want to bring in context. One of them is OIDC provider, along with JSON Web Token. These two things are golden standard for today's app economy. With that context, most of my conversation and discussion is going to be around that. We all know that federated systems are the most common way of enforcing access control. Federated identity solutions like SAML and OpenID Connect enable identity providers to validate or verify the user access at the time of authentication or login. There are scenarios where after successful user authentication, tokens have been issued, and those tokens are being used by user agents like web application, mobile application, or IoT application to access the protected resources. The entire solution is depending on these access tokens. And there are two different scenarios. One of them is when these access tokens, the lifespan of these access tokens, where it is very short-lived and very specific to a particular resource request, is going to be a happy day scenario where gateway and other backend systems can be easily validating the solution, verifying the signature, audience, scope, any other claims, and then provide the authorization to the backend. The situation I'm going to talk about is where the lifespan of these access tokens going to be long-lived, meaning their expiration dates are going to be often days. And situation like this, where the backend application is going to continue validate the signature or expiry date and continue to authorize the flow is what the problem is. Because during the meantime of this long living lifespan, user would have been revoked or terminated, user credentials would have been changed, user location would have been changed, or device compliance might have changed, or assurance level would have changed. Without knowing any of these factors, these backend applications would continue to verify or validate the signature or expiry date and our audience or scope or any other claims locally without involving the issuer and authorize for the backend access. That's where the problem is. And that's the scenario which I'm going to talk about, and which would create an issue of unauthorized access provided by the application due to this token that has been already revoked. And the situation and the solution for this situation is going to be continuous access evaluation. And how we are applying, how gateway is going to be involved, is all those things is what we are going to see as part of the next slide. As you see, we have a centralized API gateway. We also have an enterprise-wide cache management. We have a OIDC provider. Again, this is a federated identity provider for enterprise. And we do have user agents on our left-hand side where we have IoT, web, and mobile applications. And we have a messaging system, and we have backend systems. The scenario where I'm talking about, slides didn't change, sorry. Thanks. So as you guys see, we have a centralized API gateway. We also have an enterprise-wide cache management, and we have a OIDC provider and a messaging system here. As part of continuous access evaluation protocol, it's kind of a two-step process where we have a provider who needs to share the signal and the events via messaging protocol, and we also have a subscriber, the backend applications. In our case, we are going to have a centralized API gateway. So whenever the incoming request that comes in with the access token, all that we are going to do is validate that token either from a signature point of view, or if it is going to be very granular or specific, it's going to be audience or scope or any other claims that we need to. And once it is all valid, we are going to provide the authorization to access the backend system. While doing this, as I said, user would have got terminated, or user device would have been compromised, or claims would have been changed. But that information about that token is not being communicated back to our gateway. So gateway will continue to process the request, validate and authorize locally without involving without introspecting the token with the issuer. The situation to handle that, that's where we get into the continuous access evaluation protocol, where any event that occurs due to security breach or security issues that is pertaining to the user, and immediately OIDC provider is going to terminate or revoke the token, and it is going to submit that, publish that information in the form of a standard template along with the reason for the revocation, and that is going to be a signal sharing event. And once that has been published, Gateway can subscribe to that event, or any other backend application can subscribe to that event. Let's say it's going to be a revoke token queue or topic. Once that information is received, Gateway, in our case, going to be caching that information in a revoke token list or something kind of that. Once it has been cached, next time when a request comes in to the Gateway, first thing it is going to see whether it is inside the revocation list. If it is, immediately it will fail and send the corresponding reason why it was failed. And if it is not in the revocation list, then it will do the local validation and authorize the request to the backend system. That's how the continuous evaluation protocol is going to help us to deal with this kind of a revoke to token scenario using a centralized API gateway. In the next slide, I'm going to explain this in a little bit more detail. And the first part of this is going to be user authentication. As I said, federated identity OIDC provider is going to use a single factor or multi-factor and authenticate the user or verify the authenticity of the user access and issue an IT token and access token back to the user agent. And the user agent will use that and will be directing the request for accessing the protected resources. And there are two scenarios. The primary scenario here, when there is a valid token, it is going to check the token whether it is in the revocation list in the caching system. If it is not there, then it will continue to validate the token for the expiry and other claims, and then it will authorize to the backend systems and get the response back. But suppose the token is in the revocation list, it will immediately fail the request and reject the request, and it will send the corresponding information back to the user who have been requesting. Now, once this has been done, I think the use case has been well explained, and you guys are able to understand the flow with the sequence that I have explained. Now I'm going to walk through this through the demonstration of the product. Is there something I need to share, or you guys are able to see that, right? Okay. So I'm going to sign into my portal. This is a passwordless authentication where I'm using my security key. Once it has been authenticated, I'm able to get into my portal. Now I'm going to get into my continuous access evaluation protocol tile. Inside the tile, as I said, there are four individual steps. One is user authentication. I'm going to go ahead and use the authentication now. In this case, Layer 7 API Gateway is not only a centralized API gateway that processes the request, but it is also a relying party, because it is going to delegate the request to an external OIDC provider. In our case, it's going to be VIP Auth Hub. Once I log in, I'm using a biometric fingerprint for my authentication, again, passwordless. Now, after successful authentication, it consent management, where I'm granting access. At this point, the user agent is already having the access token, and I'm displaying the access token here for you, reference. And it's very valid at this point. I'm going to access the protected resources. As I said, Gateway is going to go through and verify and validate the signature, as well as audience and other claims for this particular resources, whether it is there or not. And the token has been issued, it's very valid, and now it is allowed me to access the backend system, and I was able to successfully access the API. At this point, as I said, due to some reason, whether the device got compromised or the claims got changed, the user location changed, or user got terminated, and provider revokes the token and also submits a shared signal event to a messaging, enterprise-wide messaging message broker, where he publishes this corresponding access token has been revoked, and the reason for the revocation is also mentioned. And here we can see that issued access token has been revoked because the password has been changed, the credential has been changed. At this point, this information, what happened with the provider, is not being communicated, or the user agent is not aware of that, while the gateway is already aware of it because of the continuous access evaluation protocol. It subscribed to that particular topic, and then it also received that standard template, the revoked token, as well as the reason for the revocation, and it cached in the revocation list. At this point, if I try to access the same protected resources, it is going to fail because the gateway is not even going to validate the token because it was found in the revocation list, and immediately it sends it rejects the request and says that the token has been rejected due to password change, and there is no other way you can access. The only way is, again, re-authenticate the user, and then only you'll be able to get a new token, and then only you'll be able to do that. That's the solution, using API gateway for continuous access protocol for handling the revoked token condition. That's all. If there is any questions, let me know, for the viewers virtually watching.